Welcome to Unit 3, Part 6 video. We'll talk about perpendiculars and how that can be used to find the distance between a point and a line. So the distance between a point and a line, between a line and a point not on the line, is the length of the perpendicular segment. So see how C is a point not on the line of AB. So the distance from C to AB would be the length of a perpendicular segment drawn from C to AB. So the perpendicular postulate says if a given line and a point not on the line, there exists one line that can be drawn through that point that is perpendicular to the line. So basically, anytime you have a point and a line, there's one line that you can draw through the point that is perpendicular to that line. So if you look at 36, which segment represents the shortest distance from point A to DB? If you look, there is a box here. So that segment would be AX, right? Because that's a perpendicular segment from A to DB. What's the point D to AC? What's the shortest segment from D to AC? That would be DX. Line S contains point 0, 0 and negative 5, 5. Find the distance between line S and point V. So basically, if you look at line S and you find the slope of line S, that would be 0 minus 5 over 0 minus negative 5. So it's negative 5, 5, or negative 1. So that means the perpendicular slope would be positive 1. So to go positive 1, you could either go up 1 to the right 1, or you could go down 1 to the left 1. So notice if you just keep going down 1 to the left 1, that gives you this line here, which would represent the distance. So notice this point here, that is negative 2, 2. So to find the distance between V, which is 1, 5, and negative 2, positive 2, you do the distance formula. So you go 1 minus negative 2 squared plus 5 minus 2 squared. So the distance is the square root of positive 3 squared plus 3 squared. So the distance is equal to the square root of 9 plus 9. So the distance is equal to the square root of 18, which, when you put it in your calculator, gives you 4.243 units. So that is the distance from 1, 5 to negative 2, 2. All right, so let's look at the next page. The next page says line N contains points 2, 4 and negative 4, negative 2. Find the distance between N and 3, 1. So remember, we got to find the slope of N. So it's negative 2 minus 4 over negative 4 minus 2. So it's negative 6 over negative 6, which is 1. So that means the perpendicular slope is negative 1. So that means you're either going down and to the right or up and to the left. So that means this point is 1, 3. So the distance would be 3 minus 1 squared plus 1 minus 3 squared. So it's the square root of 2 squared plus negative 2 squared. So 4 plus 4 is 8, and the square root of 8 when you put it in the calculator, it gives you 2.828 units. All right, so let's look at 40. 40 says find the distance between the parallel lines of 2x plus 3 and 2x minus 1, respectively. So if we take a point on line B, and we'll do the y-intercept, which is 0, 1, or sorry, 0, negative 1. And remember the perpendicular slope, since the lines both have a slope of 2, the perpendicular slope would be negative 1/2, which means you go up 1 and to the right 2. So up 1 to the right 1, 2, which means it crosses right there. So we have to figure out what that point is. So notice the equation of the line here would be y plus 1 equals negative 1/2 times x minus 0. So it's y plus 1 equals negative 1/2 x. Y equals negative 1/2 x minus 1. So that's the equation of line P. So now to figure out where line P and line A intersect, you set them equal to each other. So 2x minus 3 equals negative 1/2 x minus 1. So you add 3 here. So it's going to be 2x equals negative 1/2 x plus 2. You add 1/2 x. So 2 plus 1/2 x is 5/2 x equals 2. Then you multiply by 2/5. So you get x equals 4/5. And then to figure out what y is, you take y equals negative 1/2 times 4/5 minus 1. Well, that means it's negative 2/5 minus 1, which is negative 2/5 plus negative 5/5, which is negative 7/5. Sorry, I made a mistake up here because I said this is 2x minus 3. It's 2x plus 3. So that changes a bunch of stuff here. So let me just quickly do that over again. So subtract 3. So you get 2x equals negative 1/2 x minus 4. And then you add 1/2 x to both sides. So it gives you 5/2 x equals negative 4. Then you multiply by 2/5. So you get x equals negative 8/5. And then to find y, you say negative 1/2 times negative 8/5 minus 1. So negative times negative is positive, so y equals positive 4/5 minus 1. So 4 minus 5/5, so y equals negative 1/5. So the point here is negative 8/5, negative 1/5. And now you have to find the distance from 0, 1 to negative 8/5 and 1/5. So the distance is 0 minus negative 8/5 squared plus negative 1 minus negative 1/5 squared. So 0 minus a negative 8/5 is the same as positive 8/5 squared. Negative 1 plus 1/5, so negative 5/5 plus 1/5 is negative 4/5 squared. So it's 64 over 25 plus 16 over 25. So it's the square root of 80 over 25, which means it's the square root of 80 over 5. And if you type that in your calculator, you get 1.789 units. Alrighty. So why don't you try that same process out for number 41, and we'll go over the answers. First step for number 41 is to draw the two equations. So first you have y equals 1/3 x plus 1. So here's plus 1, so 0, 1. And then 1/3, so you go up 1 to the right 3. And then you draw your line. I'll do the same thing, go down 1 and to the left 3. So there is line A, we'll call it. So line B is you start at -2 and you go up 1 to the right 3 and then down 1 to the left 3. And there's line B. So now you have to pick a point. And so we'll start at 0, -2. So we'll pick a point on line B, 0, -2. And since the slope's 1/3, the perpendicular slope is going to be -3. So that means you'd either go down 3 into the left 1, sorry, down 3 to the right 1, or you go up 3, so up 1, 2, 3, and to the right 1. So that means it's going to go through this point here and be perpendicular. So if we use 0, -2, and -3, we can find the equation of the green line by going y plus 2 equals -3 times x minus 0. 2 equals -3x, so y equals -3x minus 2. So now we have to set line A equal to the green line in order to find these coordinates here. So -3x minus 2 is equal to 1/3 x plus 1. So we add 2. So we get -3x equals 1/3 x plus 3. We subtract 1/3 x. -3 minus 1/3. So -9/3 minus 1/3. So -10/3 x equals 3. So multiply by -3/10. So we get x equals -9/10. And then to find y, you take -3 times -9/10 minus 2. So it's 27/10 minus 2. So it's 27/10 minus 20/10, which is equal to 7/10. So the coordinates here are -9/10 and 7/10. So then you got to find the distance So the distance is 0 minus -9/10 squared plus -2 minus 7/10 squared. So the square root of 9/10 squared plus -2 is -20 minus 7, so -27 over 10 squared. So when you square this, you get 81 over 100 plus 27 squared is 729 over 100. So when you add 81 plus 729, you get 810 over 100, which is the same as the square root of 810 over 10, which if you put that in your calculator, you get 2.846 units. All right, so that concludes our video on perpendiculars and distance. If you have any questions, please feel free to ask. Have a good evening.